Okay, so this is the 2018 VCE Methods Exam 1, question 4. So they tell us that X is a normally distributed random variable with a mean of 6 and a variance of 4, and Z is a random variable with a standard normal distribution. So we've got X normally distributed, it's got a mean of 6 and a variance, so that's sigma squared, of 4, so that we may as well work out right now that the sigma, the standard deviation, must be the square root of 4, so it's 2. So a mean of 6 and a standard deviation of 2. Z, all they tell us is that it's a standard normal distribution, standard, which means that it must have a mean of 0 and a standard deviation of 1. So that's the initial information. Then part A simply says, what's the probability that X, that is my normally distributed random variable, is greater than 6? Okay, so what's that? So I usually like to do these visually, so I'm just going to draw a quick sketch of what this normal distribution might look like, which is pretty straightforward because it's a normal distribution. So it's just got the typical, bell-shaped curve. Its peak, the high point, it corresponds to the mean, so that's 6. And that's pretty much it. So they're asking me the probability that a particular variable from this distribution is greater than 6. It's basically anything that's in or under this part of the curve. And of course, hopefully you remember that a normal distribution is symmetrical about the mean. And because it's symmetrical, then we're talking about half of the region under the curve is greater than 6. And so that region, which corresponds to my probability, the probability that X is greater than 6, is just going to be half. Pretty straightforward. Now, for part B, let's take a look at that. So here's part B. So part B, they say, all right, find a value B such that the probability that X, my normally distributed random variable, is greater than 7 is equal to the probability that Z, my standard normal distribution, is less than B. Okay, so find B such that this is true. So again, I like to try and do this visually. So I'm going to draw a graph of each of these two normal distributions. So the first one is a bell-shaped curve. It's got a mean at 6. If you remember, it's got a standard deviation of 2. And then, so that's X. And then the other one is Z. It's going to also look pretty much exactly the same. Of course, its values are different. It's got a mean that is at 0 because it's a standard normal distribution, and its standard deviation is 1. So the question is, if X is 7, so let's say that's 7 there, then all of the values greater than 7 correspond to that. Now, what value of B on this standard normal distribution, such that if we, let's just draw a line in here that corresponds to where B is, if we were to take all the values below that, what value would, what does that have to be? Basically, we know that these two areas, that area there, the area in the normally distributed random variable X, which is greater than 7, has to be the same as this area, which is less than B, just by the symmetry of normal distributions. Okay, so the easiest way to do that is just to figure out, okay, well, 7, how does that compare to 6? It's obviously one more. What is 1 in the nature of this particular random variable? Well, 1 is exactly half of a standard deviation. So basically 7 is half of a standard deviation above the mean. That means that B must be, just by the symmetry, half a standard deviation below the mean for this particular Z distribution. What's a standard deviation in the Z distribution? Well, remember it was a standard normal distribution. So it's got a mean of 0 and a standard deviation of 1. So we've got to drop down half of one of those standard deviations. So what has B got to be? It's got to be half a standard deviation below 0, which means it's got to be minus a half. So B is minus a half. Now you can actually solve that using the Z formula instead. So I could have solved that using the Z formula. If you remember, this is Z equals X minus the mean divided by the standard deviation. Okay, so I could have used that. I'm not going to bother because I like the graphical approach. But this would have given me the same value if I'd worked it out appropriately. So hopefully that makes sense. If anyone does want me to demonstrate using the actual Z formula for this instead, just drop a little message into the video. Okay, so that's question 4, part B, and I did that obviously after 4 part A. Thanks.